Let's talk about the chemistry of alkyl halides. First, we'll talk about how to prepare alkyl halides. We can do so. We can convert. We can do so by taking an alcohol and using these reagents. We can convert it into their respective alkyl chloride, bromide, and iodide. We can convert the hydroxide group into a chloride group by heating this alcohol with PCl3, PCl5 or SOCl2. If we want to convert the alcohol into an alkyl bromide, we have to heat it with PBr3, HBr or red phosphorus with bromine gas. If you want to obtain the alkyl iodide, what we have to do is we have to heat it with Pi3, hydrogen iodide or red phosphorus and iodine mixture. That's how we obtain alkyl halides from alcohols. Another way of doing so is by hydrohalogenation of an alkene, in which if we were to add an alkyl halide, the halide atom will add to the carbon, producing the more stable carbocation, as in accordance to Markovnikov's rule, which is this carbon, because here it's bound to two methyl groups rather than this one which is bound to one methyl group, and thus the inductive effect is higher with this carbon. So the electrons are pushed towards this carbon, the positive charge of the carbocation decreases, and thus this carbocation has less positive charge and thus more stable to attack, and thereby it will produce this alkyl halide as shown over here. The hydrogen binds to this carbon. We can obtain the anti-Markovnikov product, which is also an alkyl halide, by using adding peroxide along with the hydrogen bromide, and which we get this anti-Markovnikov product, and it happens via a free radical mechanism. Now let's talk about the reactions of alkyl halides. We can obtain an alcohol from an alkyl halide by using the reagent aqueous sodium hydroxide or aqueous potassium hydroxide. Basically, in any aqueous group 1 metal hydroxide for that matter, in which case the sodium runs away with the halide group and the OH of the compound binds to the alkyl group to produce this alcohol. Here we can also obtain an alkene from an alkyl halide via elimination reaction using alcoholic KOH as a reagent. Basically, this reaction we have studied it as dehydrohalogenation, in which the chlorine runs away with a hydrogen from an alpha carbon and produces a double bond. But here I wanted to demonstrate, here we have multiple alpha carbons. This one with two methyl groups attached to it, this one with no methyl groups attached to it, and this one with only one methyl group attached to it. The chlorine runs away with the hydrogen attached to the most stable carbocation producing carbon, in which case it is this alpha carbon, via the inductive effect, has the most stable carbocation. It produces the most stable carbocation, and thus the chlorine runs away with this hydrogen to produce an alkene. Another reaction that alkyl halides undergo is this nucleophilic substitution reaction, in which if we were to add aqueous alcoholic KCN into an alkyl halide, we can obtain the respective alkyl cyanide as shown here. We can also react alkyl halides with these compounds to produce these compounds. First we'll talk about what will happen if we were to add the sodium salt of a terminal alkyne into an alkyl halide. We obtain this salt by adding sodium into the terminal alkyne to produce that salt. Basically, this thing over here is called the acetylide ion, by the way. sodium acetylide. And what happens is the sodium runs away with the bromine, and this alkyl group joins to the triple bond carbon to produce this big alkyne over here. But if we were to use a methoxide or an alkoxide ion over here, in this case it's a methoxide ion. A methoxide, we can get it by adding sodium into alcohol. What happens is the sodium runs away the bromine, and the CH3 CH2, this alkyl group, it binds to this oxygen bound to the methyl group to produce this ester over here, CH3 CH2 OCH3, and it does so via a nucleophilic substitution reaction. Another thing we can do with alkyl halides is we can add ammonia into it. If we were to add excess ammonia into alkyl halide, this here we have ethyl bromide as our example. One hydrogen runs away with the bromine, and this amine group adds to this ethyl group to produce this amine, ethylamine. If we were to use limited ammonia, what happens is all three of these H's will react with the bromines of three ethyl bromides to produce this big tertiary amine. Another reaction we can do is the production of the Grignard reagent, which is basically adding magnesium and dry ether in dry ether medium into the alkyl bromide, and we can obtain the Grignard reagent that way. Another reaction we can do is by adding a Grignard reagent into an alkyl halide, in which case we get a big alkane by the adding of these two alkyl groups, and we get MgBrCl as the byproduct of that reaction. And these are the reactions of alkyl halides.